My name is Agre Babu. I declare that the thesis submitted by me is the result of my personal research work conducted under the supervision of my supervisor. To the best of my knowledge, this thesis does not contain any research results that have been published or written by any other individual or collectives, except for those that have been cited in the text. Individuals and the groups who have contributed to the research in this paper have been clearly identified in the text. I'm fully aware that the legal consequences of this statement are my responsibilities. Okay, thank you very much. The title of my thesis is Design and Implementation of an Immersive Virtual Meeting Prototype System for Metaverse. My presentation has been divided into 4 items, as you can see there. Now we start with the research background. Okay. Research background, we say meeting format needs to be improved. Before the COVID-19, we were using offline meeting. Like there we have gathered here, we can discuss, we can eat, we can talk together. But after COVID-19, things changed, which means that we started using online meetings, whereby we are conducting meetings online, but also we are studying online. But this one, online meeting have been limited with some drawbacks, like some body language cannot be accurately conveyed. That's one of the drawbacks. But also digital human application, still cartoon style. Also, people feel a sense of distance across the screen. In that case now, we introduce another online meeting format, which have got some features with the same with the offline meetings. As you can see here, this is online meeting, but it's very convenient to online form, efficient delivery rate. So due to COVID-19, we are proposing this kind of format, which will help to reduce some drawbacks of online meetings. So we say the absence of metaverse technical support, user expectation, the integration of virtual reality, immersive experience technology, hardware and the software equipment upgrades, making the metaverse more possible. So here, what we are going to introduce is an immersive virtual meeting system. If you can have a look of my diagram here, there is this figure which shows that the image is very cartoon. But this one here, you'll find that it's more better compared with the first one. So this is where we are moving to. We are proposing this kind of meeting. Also, if you have a look here, there is a low fidelity cartoon image, this one. Now, we are proposing this kind, which are high fidelity character image, but also we say this one is not expensive in terms of equipment. For example, this is my picture, and this is my digital twin. So if you propose the kind of meeting format that we propose, it means that the image which we expect it to have is like this, and not like this one, which is cartoon style. Also, there is related works. There are some technology that relate with my work. There is Unreal Engine. Unreal Engine is we say the most used in game creation and the support other technicals such as C++, Blueprint, but also help to create games faster compared with the other software, since it is a user-friendly, but also there is motion capture. This is capture movement of objects or people, capture three-dimensional space such as locations. The space capture transform analog information into data. It can be done by combining a 3D video scanner design for for capturing human face. Also, there is virtual reality. This helps to interact using electrical equipment such as helmet with an antenna or gloves with the sensors. Solution and the effects. Here is my application scenario in which we have a physical environment. At the same time, here we have a virtual environment. Here what we are going to do is to make sure that these people who are in physical environment need to meet in the virtual environment here so that they may conduct a meeting regardless that they are far from each other, but they appear in the same screen as we are here today. And the things that equipments which we are going to use here is just an Unreal Engine, which is the main engine. Also, we have character creator. This is the software. We have Thesis Studio. We have 3D post tracker. We have 2 cameras for each user and also 1 computer. So this is the aim of what we are going to do. System design or architectural design. My system has been designed, as you can see here. It's got 3 interface. There is user interface. This one helps users to interact with the system. For example, login. There is core function. This uses to execute different programs or queries that are requested by users. Also, there is data storage. This helps to store some data or information in the system. Also, there is functional flowchart. As you can see here, it means that you can use limb data to collect your data. You will use motion capture. There is a camera here, then data will be sent to VMC data, then VMC to MOP, dynamic capture data, then it will go to Unreal Engine. Or you can use, there is user data there, there is face recognition, in which we'll use here character create as a software. Then it will be imported using the plugin which relate with that, then it will go directly to Unreal Engine. Or you can use face data, where you are going to use Face Studio as a software. Then the data will be collected there, surface capture, then it will go directly to Unreal Engine. This shows how data is captured and used in Unreal Engine to make digital people move. System implementation, action synchronization. As you can see, this is my picture here, and this is a real person, and this is a digital person, which means that all the actions which will be done with the real person will also done with this digital person. And that's we say when the user raises his hand like this, the virtual person can correspond to the user, will also correspond to action. So if the user raises the hand, this virtual person also will raise the hand. If he jump, this one also will jump. Real people are collected through the camera and they pass it into a real engine to make virtual people have vivid expressions. So that is. Also, there is this one here, system implementation, face capture. If the real person close the eye, the digital person also will close the eye. If this one maybe open the mouth, this one also will open the mouth. System evaluation, what we need to evaluate. Here, as I said, this is a real person, this is my picture. Here you can either use the face camera to collect limb data, face data, there is also limb data here. Then there is a computer here in which all data collected will be collected here. And where here we will have a software, a Unreal Engine software, which will help us to make this. This is my digital twin. And here we'll have overall interface, action synchronization effect, facial expression synchronization effect, module integration effect. System evaluation. Here I have motion capture and a face capture. Motion capture, that's data transfer. This one here was captured using a Wireshark software in which I captured the data transfer. Then I exported the captured data into Excel sheet. Then I used the Python to create this kind of graphs. The same with this one here, face capture. It was captured using the Wireshark. Then the image, I mean the data font was I exported into Excel. Then used the Python to create such kind of imaging. And if you try to compare these two things, this one here, the transmission rate here is 2.35 megabyte per second for MOP data transfer rate. But for this face capture data transfer rate, the rate was 2.52.47 kilobytes per second. And the transmission protocol is OSC over UDP. Single data content, there is 15 skeleton. Then TCP for 30 blend shape. So this one here, I used this one here. The protocol used was OSC over UDP because this one cannot stand alone, and this one here is TCP protocol. Evaluation of computation. Where here I have two client-server models. And I say in computing low evaluation, the two client-server models are introduced to explore the computing resources, requirements, and effect under different deployment models. The distribution model is that the capture software is on the client side and the Unreal Engine is in the cloud. Centralized modes such as capture software and Unreal Engine are all in the cloud. So here, as you can see, we have client, at the same time we have the server, but this can be illustrated using this diagram here. Computation evaluation result, in which we say the power consumption of the system relate to GPU utilization, this one here. So if you try to have a look on the power consumption here, you will find that it depends on this GPU utilization. Because of GPU utilization, you use more power compared with the CPU utilization. It's because of it has got many switches which contain many transistors. So here we say, if you see here, for example, we say Unreal Engine for dynamic capture software is grid and surface capture software, distribute the pressure of CPU to the client, but the total power consumption is high. Sorry. If you have a look on, for example, this here, there is CPU usage here. Also there is a GPU and a CPU. If you have a look here, the power consumption of GPU you find is higher compared with the power consumption of CPU. Here, for example, we have 24.3%, but this one is 17.87%. This is 30.26%. This is 5.76%. This is 35.43%. This is 29.53%. But okay. Also, we have research summary and outlook and immersive virtual meeting systems designed and implemented, system evaluation, meet application requirement of function serialization, performance dynamic capture transmission rate is 2.35 megabyte per second, surface capture data transmission rate 252.47 kilobyte per second. The computing resource consumption of two client server mode is analyzed. Then I got few comments from the viewers.
Coming to the last comment.
Yeah.
Your response is that more figures have already been included.
Yes. Yeah.
What are they?
For example, have a look on chapter 3. Chapter 3.
Chapter 3?
Yeah,
Which figure?
Let me show you.
What are the newly included figures?
For example, look at page 54.
Page 54.
Yeah.
So
There is figure 4.4,
Okay, another one.
VMC motion to improve. Then there is another one in page 52,
52.
figure 4.2, modeling software show. That one also has been added. Then page 50.
Page 50.
Yeah, figure 4.1, modeling. 4.1, yeah, that's.
So
I added all the hot rate figures. Yeah.
I would like to suggest that because many of the figures are very interesting, but as you have some query demand, some kind of software and some algorithms, I do not see clearly some kind of flow chart of your system. Or there's some implementation flow chart of your modules.
Okay.
Do you have any of them?
Sorry, can you?
Do you have any of the flow charts of your modules, algorithm design?
No.
No.
Yeah.
So,
the flow chart which I have is
this one.
Yeah.
These are too general. I need to tell these two.
Yeah.
You have. Can you expand?
Actually, I explained.
You explained.
Yeah.
But can you expand the details? You explain.
Yeah.
So this is the full. But this one does not like a kind of academic flow chart for the implementation.
Okay.
It's just like for business, but not for academic kind of illustration of the flow chart.
Okay.
You need to see, for example, face recognition or characteristics. Somehow the similar question in the last student, and you maybe take some of the important modules to expand the details. The flow chart. Okay.
Okay, so do you mean that I have to...
Say, for example, any one of them that you can expand with a little bit more detailed flow chart to explain.
Okay.
Say, for example, what kind of face recognition, what kind of character creator, what kind of this algorithm you have been used, you have been designed, include these kind of things.
Okay. I thought that maybe I have to explain, because if you...
They use sentences to explain, right?
Yeah.
Too many sentences to explain.
Yeah.
And I'm not so sure, but for the pages 71 and 72, you have this kind of so-called time analysis, right?
71?
71, 72, these figures. Now, this kind of some real-time measurement, this kind of this one. But can you at least include a little bit more of this kind of figures or results? Okay.
Yeah.
So my suggestion is I include a little bit more of this flow chart.
Okay.
Like academic this algorithm description in your thesis, and a little bit more this kind of research, this kind of figures. Okay.
Yeah. Thank you.
Okay.
Question. Your thesis you mentioned one single is processing in the cloud, and the power consumption is low, but in the correlation of the server and the terminal, the power consumption is higher. But in my opinion, I think by correlation of the server and the terminal, the power may be lower than the cloud server. So I actually want to know how to evaluate the power consumption.
You mean here?
How do you evaluate this?
Yeah.
Power, these numbers. Where did you get them?
This one I used the MSI afterburner to get them.
Have you introduced in your thesis?
Yes, I introduced.
Which page? data history. But you cannot just say how do you measure this power? How do you get these numbers? You just mentioned there.
72.
Sorry?
72.
72.
Yeah. The evaluation tool is a cipher banner that has an average of 3 measurements.
The evaluation tool is an
Yeah.
SIA. Okay.
Yeah.
Can you either include some references to this one and include a little bit more information about this?
Okay. Okay. Thank you.
So every single this kind of results or the digits,
Yeah.
numbers, should we have some reference? You cannot simply just put these numbers.
Okay.
Here you have evaluated the power consumption, and another question is you evaluate the latency delay.
Yeah.
Well, that means you do the same process in the cloud or in the cloud edge. So how about latency for the different methods?
Delay.
Transmission protocol.
Is it a real-time one or?
If you maybe for the case of this mock capture data transfer rate, if you the protocol here was OSI over UDP.
Yes, we
But this-
understand. So we do not do the calculation, right? In this thing, you do you did the calculation offline and include this kind of calculation into your thesis.
Okay. Yeah.
Another question is some section is too long. For example, section 3.2, this section covers 12 pages.
Okay.
So maybe you can divide this section into several
Subsections.
Yeah, subsections.
Okay.
And add some subtitles.
Okay.
I think that's all.
Thank you.
So you mentioned there are two types of transport layer protocols that have been used, UDP and TCP, and you also have this traffic measurement in this chapter 4.3.1.
Yeah.
So one question, you are using UDP for transmitting the motion capture data.
Yeah.
What do you say? UDP is not guaranteed, right?
Yeah, of course it's not guaranteed, but it is faster.
Yeah, it is.
Yeah.
But say from the comparison here, it is faster, but what is y-axis? It is, see from this, the y-axis is a different one. One is megabits per second.
Yeah.
Another one for TCP is kilobits per second.
Kilobits per second.
So which one is higher? See from the throughput, total transmitted packets. Which one is higher?
It's high, this one.
Okay. So what if there are packets from sending according to UDP protocol that has, like, say, lost, and the other side what has been like rendered on the screen? Because UDP, it is faster, it is quicker, but it is not guaranteed. Packets might be lost. What if some of the packets lost? Do you have any guarantee, or you just display the incomplete rendering? Let's say this figure right here.
Yeah.
Can it be rendered if some of the packets is missing?
Yeah.
Can?
Yeah.
Can you show some, like, if it can be done? I'm suggesting you, if you are presenting a traffic measurement result, I'm suggesting you to present this performance or image quality when some of the packets or a certain ratio of the packets are lost, and how can it be still rendered on the screen? Okay.
Okay.
Otherwise, it is useless to compare using this UDP and TCP.
Okay.
That's all.
Your thesis is the only one that I can see. Written very well.
Thank you. Thank you very much.